Min enters the numbers 1 through 81 into the cells of a 9 by 9 grid in some order. She calculates the product of the numbers in each row and column. What is the least number of rows and columns that could have a product divisible by 3? Okay, 9 by 9 grid. Well, if you got, so it'd be divisible by 3. It's something's divisible by 3 if the sum is divisible by 3. Or just, divisible by 3 if it has a 3 in it. So if we got all numbers that don't have a 3 in it, so like 1, 2, we'll skip 3, 4, 5, 7, 8, 10, 1, 2, 3, 4, 5, 6, 7, 11, and 13. So have all those least number of rows and columns that could have a product least number. So I think it's just finding out how many numbers are divisible by 3. So we have 3, 6, 9, and this is going to go all the way to 81. So 3 does go into 81. So this is 3 times 1, 3 times 2, and this is 3 times 27. Yeah. So there are 27 numbers that are divisible by 3. So that means that there are 81 minus 27. That means that there are 54 numbers not divisible by 3. So if we get all these numbers together in rows, we could have a set of 9, set of 9, set of 9, group of 9 numbers. And let's say these are all the rows. These are the 54 numbers. All these numbers are not divisible by 3. Therefore, it's talking about their product. Therefore, their product is not going to be divisible by 3. So I'd say we can make we could have 6 rows here. What is the least number of rows and columns? Least number. Talking about least number. Right. So least number. So if 6 rows are divisible by 3, then that means that this is a 9 by 9 grid. So that implies that 3, are not divisible by 3. That means that 3 rows are. And then if I was only focusing on rows, it's going to be true that 9 columns are divisible by 3. And this is looking at both rows and columns, so I would say maybe 12 is the least rows and columns, but I just focused on rows. I mean, if we use the numbers a little more efficiently, we could have, like if this is the 9 by 9 grid, let's say there are, in this row and this column, there are 17 numbers. We have 54 numbers we can work with. So this is one row, one column. And then if we go here and consider this row and column, we're using 2 of the numbers that we've already used before. So the number of new columns, one row, so we've used 17 numbers here. One row, one column for the second time is going to be, we've used 16 numbers. And then again, if we do the same thing, one row, we do the same thing here. So go down, down, and these numbers are all apart, these numbers are all apart. Wait, was this 16? No, this may be 15 actually. So this whole row is 9. So in terms of new numbers that we've used, we used 8 new numbers plus and then this column 7. So actually this is 15. Then if we do another one row, one column, like this here, so in the column, or rather in the row, the number of new numbers that we have here are 7, and then the number of new numbers in the column is 6. So this is 13. So 17 plus 15 plus 13 is 45. So and then then if we go down again, so far we're up to 6 here. If we consider this row here, this is new numbers in this column. 6 new numbers. Yeah, then we'd be up to 51. We wouldn't be able to go beyond there. My thinking may not be super clear to people, but I think this means 7 rows and columns with this new method, not looking at like just singular rows, but like doing it like this. Yeah, so then we're going to do what is the least number of rows and columns that it could have a product. Yeah, so total rows and columns, there are there are 18 rows and columns minus 7 is 11. I would say answer is choice D.